This is Daniel Coosbury, and in this lecture, we're going to start looking at graphing qualitative data. So we have moved past talking about how to sample and get a good data set, and now we're in a context where we have the data and we're not quite sure what to do with it. And so a really good first thing to do is to graph it somehow and see what it looks like and what are some characteristics of it. And once we have a graph, we can decide kind of what statistical things we want to do next. So these next few videos are going to focus on graphing data. So we'll start out with graphing qualitative data, which is the categorical data, the not numerical things. And so let's start with something that we're going to need to do first. Here's a data set. So this is a qualitative data set. It's a bunch of things we asked. We had a retailer that accepts 4 types of credit cards and lists the types used by the last 50 customers. So there's 4 different kinds of credit cards here in order. And we want to summarize this data set because right now it's a perfectly fine looking data set. It's just ugly. Like I can look at it and I don't really know what I'm looking at because there's a lot of Visas on there and the MasterCards on here. So what's not terribly useful is just giving this to someone and say, here, look at this data. Look at all this cool stuff. What's useful is to try to graph it somehow by putting it in a table and then putting it in some kind of a graph. So let's start with the table idea. So we'll start by making a frequency distribution, which is a table that presents the frequency of each category in the data set. So we have 4 different types of credit cards, and the frequency is just a fancy word for how often does it occur in the data set. So if you go back, you can count, go back in the video, you can count MasterCard occurs 11 times. So we'll put the frequency as 11. We had 23 Visas swiped in that data set, 9 American Expresses, and 7 Discovers. And that's the entire data set. So we've already done something really nice by making what's called a frequency distribution. So this term is referring to this table, frequency distribution. Because this table alone already shows us some things. Like I can see the most frequently used credit card is the Visa, and the least frequent is the Discover. So even just taking a big jump from something ugly and awful like this to a nice frequency distribution helps us out. Now, once we have a frequency distribution, we can make a bar graph, which is really nice and easy to make. So what I've done, I've showed you the frequency distribution at the bottom, and then the bar graph is up top. So the bar graph just shows the frequency of each data point. We've seen things like this before, but it's a nice visual representation where you can see that the Visa is not only the largest or the most frequent, but it's also over twice as tall as this MasterCard one, which is interesting. Maybe you wouldn't have seen that from the table, but you see it from the bar graph that it's not only the most frequent, but it's the most frequent by a lot. And then the Discover and American Express are both pretty not used at all. So one thing we can do with qualitative data sets like this ugly one is we can turn it into a frequency distribution and make a bar graph. So that's one takeaway from this video already. In addition to just counting the frequency, I forgot about the Pareto chart. The Pareto chart is a special kind of frequency, it's a special kind of bar graph in which we can take the exact same frequency distribution. So this is the same table. I just keep putting it on more slides. And all the Pareto chart does is it represents the frequencies from greatest to least. So usually when we make it, we'll put the biggest one first because we're dealing with categories. Like they can go in any sort of way if they're nominal data at least. So we'll go from the biggest to the smallest. And you usually do it like this. It's called a Pareto chart. You do it like this if you want to highlight the most frequent category. Sometimes it's really nice when the most frequent category is not only the highest, but it's so much the highest. Like in this case, if you want to highlight, most of the data is actually here. Then you do something like a Pareto chart. And then if the rest of these are less frequent. But anyway, it's your call whether you want to do a regular bar graph like that in no particular order or a Pareto chart where the biggest, you go from biggest to smallest. In addition to frequencies, we have what's called a relative frequency distribution. So we might be interested in what proportion of the whole data set falls within a particular category. So not only its frequency, but we can find proportions from the frequency. And you do that by, oh, I thought I had a pen here. Let's see if I can get it back. All right, got it. You do that by, you can find proportions by dividing the frequency by the total number of data points. So this is our formula for relative frequency. So if you already have the frequency of a category, so let's just pretend this is Visa, which I think was 23. The frequency of Visa was 23, and the sum of all the frequencies is the total number of data points, which is 50. So you could find the relative frequency for Visa by taking 23 divided by 50. I write it kind of like this, the frequency over n, which is the sample size. It's the same thing. So relative frequencies are going to give you the frequency within the whole data set. And since they're relative frequencies, we're dividing by the biggest number. They're all going to be between 0 and 1. And this is an example of how you'd find a relative frequency distribution. So here's the frequency distribution. We just counted things and put them of the frequency here. And then since we have 50 data points, so our n is 50, then we take all 4 frequencies and divide them all by 50. So that's what's going on here. And these are your relative frequencies. So what this tells us is, rather than saying there's 23 visas in the data set, this is telling us that in the data set, 0.46 of the whole is visas. Or you could say, if you wanted to say it another way, you could say that 46%, we have the decimal 2 places, of the data are visas, and 18% are American Expresses. So that's actually kind of a nice thing to be able to say. But you wouldn't put the percents in the table. Usually our relative frequencies are given by the decimal versions of that. So don't move the decimal over 2, just leave it written like that. Those are the proportions of the whole for relative frequencies. Once we have relative frequency distribution, so I've just put those numbers down here, you can make what's called a relative frequency bar graph, which instead of having the frequency, it has the relative frequency for the heights of the bar. So instead of this being 23, it's the relative frequency, which is 46%. And so you've noticed these y-axis numbers have changed because now it's only going up to like 50%, 0.5. But you see these bars actually look a whole lot like the original bar graph. In fact, here's a picture of them side by side. So here's the frequency distribution, and here's the relative frequency distribution. And the only thing that's really changed is that our y-axis on the relative one has turned into decimals, whereas here it's counting the number out of the whole data set. But otherwise, the bars are the same height because they're like with respect to each other. This one's still twice as much as that. This is still twice as much as that. Like that all actually works out and makes sense, and it's really nice. But you may be interested in relative frequency. For instance, if your sample size, let's just say you had 2 samples, and we have one sample that has 50 things in it, and maybe another day we do get credit cards and our other sample size is 300 instead of 50, and we wanted to compare those 2 data sets. Well, it might not make so much sense to put the frequencies next to each other because of the 50 cards, they're only going to get so high. But if we were to plot like the 300, well, one of them is going to go like way up there. Man, sorry, I'm still learning how to use this. One of them is going to go way up high, and the other one's going to be high. Like one of those might be 150, and one of those might be 70, and all of them are going to be much bigger than these things. That it may make more sense if you have 2 data sets to plot the relative frequencies side by side instead of the actual frequencies, because the relative frequencies are going to be numbers between 0 and 1, whereas the actual frequencies may not be easy to compare. So if you have 2 data sets, it might make sense to look at the relative frequencies, because then you can compare what's going on a little bit easier. Another thing you can do with relative frequencies is you can make a pie chart. So we've seen these before. This just shows what percentage of the whole each category makes up. And these are the exact same numbers we had from the last bar graph we had. This is the relative frequency distribution. And the only real difference about how it's represented in a pie chart is you actually do use the percentage instead of the proportion. So you would move the decimal over 2 and then add a percent sign. But this is stuff we're familiar with too. But we couldn't make it until we had the relative frequency distribution. And now we can say, okay, well, this is the percentage of the data that's here, and this is the percentage of the data that's here. So really useful things. These are techniques we want to use when we have qualitative or categorical variables, because our data sets are almost always just going to look like this, just a bunch of words or categories. And we've got to group them in nice ways in order to make graphs. So the way to group them is to make a frequency distribution. And then if you want a pie chart or you want to compare them to other data sets, go an extra mile and make a relative frequency distribution. So you count them up, put them there, and then you divide by the sample size to get the relative frequency. And then you can make any kind of graph that you want.